In this tutorial, I'm going to demonstrate you the use of Energy2D software. You can get this software from the website of Energy2D for suitable operating system. After downloading and installing the software, you will get into this window. This is the main window of the software, and you can see that there are few menus that you can work on, and this is the plain template where you can build your own geometries. For example, if I'm trying to build an oval, and for example I'm considering it to be a source of heat, then I have to right click and go to the properties of this geometry that I just created, and I can also define the centers. If I'm not satisfied with the placement, then I can define the suitable placement, and I can also define the width and the height of this oval, and if I click OK, then it should be there in the center that I defined. And I can also define the background temperature, which is at 0 degree centigrade at the moment, but I can, for example, say it as 10 degree centigrade. And then there are different properties of the fluid that is in the background, so I don't change it at the moment, but there are these small icons where you can choose whether to include the effect of convection or not. If I just untick it, then the convection effect will not be taken into account. And there is this sunny effect as well, so if you want to consider the effect of the sunshine radiation effects, then you have to tick it on. And for now I'm just clicking the convective effect on, and there are other parameters of the sun rays as well as other parameters. Then you can select for the case of the background, and once I do that, then the background color will be changed according to the temperature that I just set. And if I go to the property of the geometry that I created, and I can see that the geometry is there. It is the same as what I set a few minutes earlier. And in the temperature section, in the source section, you can select whether the body and that I created is a source of heat. If it is not the source of the heat, we still need to define the temperature. We can define the constant temperature of the body as well. If we are creating that kind of the effect where the temperature of the body is not changing, then we have to tick it on. And if we are supplying the constant power, then we have to go to the third option and define the power density, which is in watts per meter cube. And for now I'm going to take the first option and say that the body is at the temperature of 400 degrees centigrade. So it is a pretty high temperature body. And now if I just go and press the run, then I can see that the temperature of my surrounding is changing quite drastically. And if I again go to this body and, for example, change the temperature to 40 degrees centigrade, and I press reset and then run, then I can see that there is natural convection taking place. The speed of the convection is quite less than the previous case. I also want, for example, to see the temperature, so I place this thermostat somewhere in this position. You can also change the position of this thermostat by right clicking on it and pressing the properties button. And there is only natural convection taking place at the moment, so the heat from the body will tend to rise upwards. You can also go to the properties and select the time step. If you think that your solution is moving quite fast, then you can select the time step. For example, I'm reducing my time step to 0.02. If you do that, I reset it once again, and you can see that now the solution is changing quite slowly. Yeah, so these are the things that you can do in this plain window. So if you open this blank template, then you can set your solutions from scratch, and you can build your own geometry, you can develop your own properties. But in the second case, you can also go to these examples and change the properties or geometries of the things that are defined in the examples, and then you can run your own simulations like that as well. For example, I'm going to this building energy analysis and going to the fireplace, for example. So you can see that there is this ready-made solution, and if you just run it, then you will be able to see that because of this heating board which is placed in the bottom of this room, the temperature of the room is changing with time. And there is also this small thermostat which is measuring the temperature. There is also this fireplace. What I'm going to do, first of all, if you want to see the properties of any of the objects that are defined here, you can go to the right click properties, and you can see how the materials have been defined. For example, thermal conductivity in this case is 0.001, specific heat is 1300, density 25, and similarly there is this small glass, and you can see how the properties of the glass have been defined. And if you want, you can change these parameters as well. If you don't want any of the objects, for example, I don't want to see this heating board at all, then I can just right click and I can cut it, or I can just press delete. For example, if I stop this simulation and if I click it and delete this object, then I can see that the heating board is no longer there. And if I now click run, then I can see that the only thing that is moving in this whole window is the fireplace. There is no medium which is bringing the fire into the room. That is why because of the convection effect, natural convection effect, the heat from the fire is actually going upwards. So this is one simulation. But if you want to see, for example, if I add one fan, for example, in the fire, like this, for example, this is a fan which is facing towards the room, so we have to also right click it and define the velocity of this fan. For example, I'm now defining it to be 0.1 meters per second. That is the velocity of the fan. And now when I have defined the velocity of the fan and I run the simulation once again, then you can see that the fan is actually acting like a suction, and it is transferring the heat from the fireplace back to the room. And we can also see that the temperature is rising in the thermostat. And actually I can also see the change in the temperature graphically. So when I go to right click view option, then there is this option of the graph, and when I now run this simulation, then I can see that the temperature is rising slowly. But if I change my y-axis, refresh it, then the range of the y-axis will change, and now I can see that my temperature of the room is rising drastically. So it will keep on rising as long as we run the simulation, and should reach to some stable state at some point. But now, since the time step is very small, so the rise in the temperature will continue for a long time. So for now I stop this solution and I stop the graph and reset. So now you can save this solution somewhere else. For example, fireplace. So this is how you can use the Energy2D software. You can either develop your own geometry and start from the scratch by defining all the properties of the geometry, and alternatively you can also use the examples that are given in the software itself, and you can change the parameters based on your requirement. You can add, subtract geometries, so that can make your solution much simpler.